In this section, we'll look some more at functions and their graphs. A function is increasing if it goes up from left to right, and it's decreasing if the graph goes down from left to right. We always read graphs from left to right, just like you read a book. A function is constant if it goes straight across. To write the intervals for functions when we're describing increasing, decreasing, or constant, we use the x values only, not the y coordinates. So this graph, we want to talk about where it's increasing, decreasing, or constant, and the arrows on my graph got chopped off. But if we start by looking at the graph from left to right, we'll start with this side right here, and we see it's going down until it hits right here. And then it changes direction, and it starts going up until right there, and then it changes direction, and it starts going down, and then it changes direction, and it starts going up. So we're just tracing it from left to right. So the parts where the graph is going up that I drew in orange are the increasing parts. So we look at those increasing parts and we say, okay, what x value did it start increasing at? And it looks like maybe negative 1.5. So I'd put a parenthesis and I'd write negative 1.5. And then I look at the x value of where it quit going up. So that x value is 0. And then the x value over here, where it starts going up again, is 1.5. And then the graph keeps going up, it doesn't stop, so it would keep going up for infinity. We could put a U between these two pieces connecting them together. And so it shows that we have two sections of increasing graphs. Okay, so now let's look at the decreasing. So decreasing, we can see the graph, reading from left to right again, starts decreasing. So there's not a place where it just is always decreasing from the very beginning. There's not a place where it was increasing before that. So it means the x value where it started is really negative infinity. And then it stops decreasing right there. Again, we'll just call that negative 1.5. And then the next piece starts decreasing at 0, and then stops decreasing, stops going down at positive 1.5. And again, we could put a U between them. Now, constant we'll see in a minute, but this graph doesn't have anything that just goes straight across. So there's no constant. So again, we'll look at this. Again, my arrows got cut off on my graph. But the graph starts by going down till right there. And then right there, I'll just go ahead and sort of draw our line up to the x-axis. It starts going up. Okay, so this graph starts by going down. It's decreasing first. So it would be negative infinity to that spot where it stops going down, which would be 2. And at 2, it starts going up or increasing, and then it increases for forever, so it would be infinity. And again, this has no horizontal sections, so it just stays constant. It doesn't have any constant values. So if we look at this, we can see that it's horizontal straight across for the whole entire thing. It starts horizontal at negative 2, so that's the constant part. And then it stops being horizontal when the graph ends, because there's no arrows, at 4. Everything in between is constant. Now there's no ups and there's no downs. There's no increasing or decreasing. This graph just has constant pieces. A relative minimum is the lowest point in a neighborhood, and a relative maximum is the highest point in a neighborhood. And I'll show you what I mean by neighborhoods in just a second. we use the x to describe the place of the relative max. This answers the question about where it happens. And we use the y to describe the value. So value is the key word here. If you see value, you need to think y value. So let's talk about the minimums first. The minimums are the low points. They're like the valleys. So there's a minimum there, and a minimum there, and a minimum there. Relative minimums, you can have as many valleys as you want on that graph. So where are they? That's asking for the x value. So here, if we look at the x value, that would be maybe negative 3.5. Here, the x value is 0. And here, the x value is maybe a positive 3.5. The values is asking about the y values, so we'd follow this point over to the y-axis, and that maybe is a negative 8. This value here is 0, and here we'd follow this one over to the y-axis, and we get the same thing, negative 8. Okay, so let's talk now about the maximums, relative maximums. This graph, my arrows got chopped off again. So the relative maximums happen here at the highest point, like the top of the hill and the top of the hill. Now we can't talk about these arrows because they keep going for forever, so there wouldn't be a relative max there. So where are they? That again is our x value, so we'd follow it down. We get negative 2 and positive 2. And then the y value, the values again is the y value. So from here we go over, and it looks like we get 12 maybe. And then here we go over and also get 12. Now an absolute max is the highest point on the graph that has endpoints. There can only be one of them. And the absolute min is, the lowest point on a graph that has endpoints, and there can only be one of them. So part of the requirement for absolute max and absolute min is it has to have endpoints on your graph, and then you need to consider those endpoints as possibly the highest or the lowest part of the graph. So in this graph, first of all, I want you to pretend like this piece right here is not there, and this piece right there is not there. I couldn't get it to work in the computer. So the graph ends where the dots are. So what are the values of the relative minimums? So let's talk about this. Here's a relative minimum, here's a relative minimum, and here's a relative minimum. So the values, again, they're asking about the y values, and quite often these questions word it asking about the values or the y values first. So this would be negative 10. This one would be 0. And this one would be, looks like, I don't know, maybe negative 15. And then it says, and where do they occur? They occur at, and then we look at the x values at those same points. So here, this right here looks like 3 where it crosses the x-axis. So it's negative 3, I mean. So let's say negative 3.5. And then this one is 0. And then this one, again, this looks like it crosses at 5, so I would call that 4.5. Okay, so let's talk about the relative maximums now. So the relative maximums would be here, 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 and here. So when you have endpoints, you need to think about those as being possible relative maximums or minimums. So the first part asks for values. Again, that's a y value. So if we look over here, that looks like maybe 45. Here, that looks like maybe 18. Here, that looks like it's just above 40, so maybe 42. And then here, maybe 32. And then it says for values, so that what happens at, so we have to go down to the x-axis here. So maybe negative 4.5. This one is right at negative 2. That one maybe 2.5. And then this one maybe 5.5. Okay. Let me clean that up a little bit so you can see things. Okay, so now let's talk about the absolute max. The absolute minimum. The absolute minimum is the smallest value, it is the lowest point. So that lowest point happens right here. Okay, so the value again is the y value. You'd follow it over, or we can see it, we have it right here. It's negative 15, and it happens at, you could go up right here, or we could just read it from right here, 4.5. And the absolute max is the highest point, and the highest point happens to be this end point. So we could follow it down, or follow it over to the x-axis first, or the y-axis this way, first to find the value. Or we could look at our list right here, and the biggest y value is 45, so we know that's our absolute max. And the x that went with it is negative 4.5. Even and odd symmetry. Even symmetry, the official definition is that is symmetric about the y-axis. And odd symmetry, the official definition is that is symmetric about the origin. In an equation, when we're finding even symmetry, you replace x with negative x and simplify. And if the result matches the original equation, it's even. If we're talking about odd, you have to replace x with negative x first, and then you return to the original equation and multiply everything by negative 1. And if these two equations match, then the function is odd. Graphs are pretty easy, or pretty quick to look at even and odd. An even graph, if you fold it along the y-axis, then the two sides would match up perfectly. So think about just folding it in half along the y-axis, and the left and the right side should line up. If the graph looks the same up, side, down as right side up, then the graph is an odd function. So let's look at some examples. You can see here that if you folded it along this y-axis, that the right side and the left side would match up perfectly. That means this graph is even. In part B, if you turn your paper upside down, it will match exactly the graph you see on my screen, on your computer screen. And that means, because it's the same upside down and right side up, that it's odd. And one more, again, if you turn your paper upside down, it will match exactly what you see here on the screen. That means that it's odd. Now a graph can be either even or odd, or it can be neither of those. It doesn't have to be one of the two. Piecewise functions. In a piecewise function, the function that is separated into pieces, and the x values determine which piece to use. So first of all, let me get my bracket in here because the computer cut that off. But in the first problem, part A, this 45 is telling us that x is equal to 45, or in this case it's t instead of x. Okay, so we have to look over here on the right hand side first to see whether we're using the top or the bottom row. 45 fits between 0 and 60, so we're using the top row. So that means that we look over here and we just copy what's here. And that's our answer. Okay, so let's try again. In part B, we see that t is equal to 60. So we look over here and we say, okay, where does that fit? Well, it fits again in the top row because of this equal to part right there, less than or equal to 60. So again, we go over here and we just copy what's there. The answer is 20 again. So let's look at part C. Here it says t is 90. So we look here, and that fits in the bottom section because 90 is bigger than 60. So we're going to use the bottom row, so we copy what's here. 20 plus 0.40 t minus 60. Now here it told us that t was 90. So we're going to take that 90 and we're going to stick it in place of that t. Now in part A, there was no t to replace t with, and same with part B, so we just had to write 20. But in part C, we have to actually find that number. So we'd have 0.40, and then we'd put in 90 minus 60. And I would just type that into your calculator all at once. Don't do it in parts. And you should get an answer of 32. Okay, in this problem we're going to graph it. So we'll start with the top row. And we're going to make an XY chart. So for the top, we want x's that are smaller than or equal to 3. That's what this is telling us here. So we'd have 3, 2, 1, 0. And for all of those numbers, we just look over here and you can see that it's telling us that every single time we get 3 as an answer. So I get 3, 3, 3, 3. And this is an XY point. The first number tells me to move right 3. The second number tells me to move up 3. And I graph my point. The second point tells me to move right 2 and then up 3. The third point tells me to move right 1 and then up 3. The fourth point tells me to move right, don't move right or left, just move up 3. And this also tells us that we keep going in the negative direction to infinity, so our graph for that piece would look like that. So now let's do the bottom. So in the bottom, we want numbers that are bigger than 3. That's what this is telling us. So we choose 4, 5, 6. But we also need to do at 3. So I'm going to put a little line, a squiggly line. I'll show you how to deal with that in a second. So to find the y values, we just stick that into that equation. So 4 we would put in place of x right here. And so we'd say 2 times 4 minus 3. If you figure that out or type that into your calculator, you get 5. And then 5 in there would be 2 times 5, which is 10, minus 3, which is 7. And then 6 in there would be 6 times 2, which is 12, minus 3, which is 9. And then 3 in there would be 2 times 3 is 6, minus 3 is 3. So let's graph these first 3 points. Over 4, up 5. Over 5, up 7. And over 6, up 9. You kind of just have to write it off the graph there. And now this 3, since it didn't say equal to 3, it just said greater than 3, we would graph, but we'd graph it with an open circle. So instead of having it filled in, there'd be sort of an open dot right there. And that's where we'd start graphing. We'd draw our line through those points. And then it keeps going, so there'd be an arrow. And that's the graph of that function. So this is the same idea, it's just that we have 3 lines now. So the first one says x is equal to -1. So this is where x is equal to -1. So we look over here and we get -2 is our answer. And we use the middle row. Here it says x is equal to -3. -3 falls right there, it's the top. So we look over here and we get 2x plus 1. But we know x is -3, so we have 2 times -3 plus 1, which is -6 plus 1, which is -5 for our answer. So here we have x is equal to 1. That's right here because of this equal to 1 part there. So we look over here, we use the middle row, and the answer is just -2. Here we get x is equal to 0. And if we look back over here, 0 falls between -1 and 1, so we're still using the middle row, which tells us that our answer again is -2. And finally, we get x is equal to 5. And this is where we get numbers that are bigger than 1. So we're using the bottom. So we stick that, we'd have x minus 3. Put that 5 in place of x, so 5 minus 3. And we get 2 is our answer. Let's do one more graphing problem. Okay, so we're going to do the top first. So the top says greater than 1. So we're going to, or smaller than 1. So we're going to write 1 on there, but it doesn't say equal to, so we're going to kind of keep that separate. But then I need to go smaller than that. So 0, -1, -2. So if I put 1 into this, it'd be -1 plus 1 is 0. If I put 0 into it, 0 plus 1 is 1. It's a little tricky here, but this one will be negative and then -1 plus 1, which gives us 2. And this one would be -2 plus 1, which is 3. So let's graph that. 1, 0, remember, is an open circle because it was not included. 0, 1 is a point. -1, 2 is a point. -2, 3 is a point. So we'd start here, and it would go off like that. Let's do the bottom. So this says greater than or equal to 1. So we'll start with 1, 2, 3. We look over here and it says just if x is 1, then it tells us this is the same thing, y is 1. If x is 2, y is 2. If x is 3, y is 3. So we'll graph that. 1, 1, 2, 1, 2, 2, 3, 3, and it would keep going like that. So in this case, you can see our two pieces don't match up. They don't have to. They can jump.